Okay, so in the last lecture we discussed creating the three basic data types. Those were integers, floating points, and characters. Now today we're going to talk about an extension to the character data type, and that is the string. Now there are two ways to initialize a string. The first is by doing this. This little asterisk here before the variable name initializes this as a character pointer, but seeing as we're not at that point in the course yet, we're not going to use this, and it also doesn't lead quite as nicely into the rest of the video. But still use this for a visual example. So I create this string. A string is a collection of numbers and letters, ASCII characters, remember from the last video. And they are placed between this double quotation mark. There should be a semicolon at the end of that line. So anything between two double quotes is a string. If you remember, a character looks like this. A character is anything that is in a single quote. So single quote is a character, double quote is multiple characters. Oop. So if I get rid of that, and if I run this, you can see it creates the output string hello world. So exactly what we created. So that's one way to initialize a string, but we're not going to deal with that because we talk about specifics of this later in the course. No, today we're going to do this by creating an array of characters. And so that's what today's video and course is, or lecture is. It's about strings and arrays. So I'm still going to call this variable str, but I'm going to put at the end of this name an open and closed square bracket. Now this initializes it as an array. Now an array works sort of like this. If I were to create character, and we'll call this A1, character A2, character A3, I can create multiple characters but reference them all from a single variable. So it's, well, you'll see how that what that means later. So this creates it as an array, and in order to, there are two ways you can create this array. First is by giving it a size. So if I put in 10, this is a character string, or this is a string of characters size 10. So there are 10 characters you can access from this variable, indexed 0 through 9. Thing to remember about computers is, and most programming languages, is that they don't start at 1, they start counting from 0. And you'll see what that means in a couple minutes. So I can create this array as being 10 characters long, but it won't have any values. It won't have any variables. So if I try and run this, you can see, just like creating an uninitialized integer or floating point, it doesn't have any real value to it. It's just a bunch of random it's just a bunch of random characters. So the second way to do this is if I put back the open and closed brackets, and in between curly braces, I can put in the string. So I can put in hello world. If I run that, you can see it creates hello world. And it creates, when the program compiles, it creates this array that is just the right size for this, which is called a string literal. So when the program compiles, it essentially does what I did before. It puts in a size for this, however many characters that is, and then initializes all of the correct spaces to hello world. Now you can also do it without the curly brackets. It does exactly the same thing. But the reason I do it with the curly brackets is because when you initialize other arrays, you use curly brackets. So I like to use the curly brackets to say, yes, this is in fact an array, and this is the values that are initialized to it. So I'm just going to leave the curly brackets in. Now, this is an array, which means that it's essentially many variables that you can reference from just one name, and that name is whatever you call this. So if I were to use the open and close brackets again, and put in 0 and run this, you see we get H. And if I change this to 1, you get E. If I change this to 2, you get L. Looked like a 1. If I change this to 5, you get a space. So what I'm essentially doing is referencing each of the characters individually by using this square bracket. Now, remember I said this starts counting at 0, and it goes through the length of the string. So this string would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's 12 characters. The space counts as a character. So this would start counting at 0 and ends at 11. So if I put in 11 and I run this, we should get the exclamation point. Oh, and yes, we do. So that's how you create a string. Now, a string is used to print messages, to receive input, to give output, all these sorts of things. That's how you deal with a variable, and you can get specific characters of the string to do various things with. So I can change this. So I can say string character 4 or 3 or 4 equals Q. And if I just make this print string again, you can see I changed the O to a Q. Now, I put the Q in single quotes because this is an array of characters. So any single element in the string is a character, and it should be treated as such. So it's put in single quotes. Now, there are a few caveats to creating strings. Namely, there are some characters you can't put in without certain formatting, and these are called escape sequences. So this is a string literal. Now, in order for C++ and other programming languages to know when the end of a string is, it creates something called a null terminator. Now, the null terminator is put at the end of the string. Now, this array is actually 12 characters long. You don't see what the 12th character, or 13 characters. You don't see what the last character is because it's not printed, because it's a null character. What that means is it's the end of this string. So you can just Google what the escape sequences are, and you can see what they do. So like there's a single quote. It's a slash and then single quote. Now the reason you can't put a single quote in, or you can't put a double quote in, is because C++ treats those as programming things. See how I create the string by using double quotes, and I create a character by using single quotes. C++ needs those. So in order for C++ to know, oh, you mean a double quote in the string, you have to use the escape sequence. So there are several. There are some special modifiers, like you can create a backspace, or you can create a form feed, or you can create a new line, and you can create tabs. So if I were to replace this space here with a T, and I get rid of this, and I run it, you can see in the middle it's no longer a space, but it's actually a full tab. So you can use these to create formatted outputs. You can use this to create tables and all sorts of things that make it look nicer. This also works very well when creating file output, when you have to create formatted files, like comma-separated files, which are used in Excel, that sort of thing. But things we'll get to later. So it's good to know now, and where to find the escape sequences and how to create these strings now, how they work, and why they're important. Okay, so that's creating strings. Now, a string, like I said, just a character array. You can do this with any other data type. So I can create an array of integers, and I'll call that R, and I will initialize it with the values 1, 2, 3, 4, 5. And if I test this, make sure that's right. Yes, okay. So the thing about this is, if I ask it to print R, it doesn't print out 1, 2, 3, 4, 5. That's because this command here isn't formatted to handle an integer array. I can only print out specific elements of R. So by printing 1, remember, it starts counting from 0. That's called 0 indexed. So by asking for integer array in array 1, I get 2. Where'd that output go? There we go. So you can't print out the entire thing without creating a loop, which again we'll talk about later. But this is useful for storing lists of data and then accessing individual elements in that array without creating a whole list of variables. And you can access each one with a specific index. So like I said, useful for creating lists, tables, and all sorts of formatted data types without creating specific variables like I did earlier, A1, A2, A3, A4, so that you can access them programmatically. And so that is how you use strings and arrays in C++. So now let's go over some of the common errors that you can get with this, as I try to do at the end of these lectures. If I say with the integer array, don't put a value at the end of this, and I try and compile it, it doesn't actually complain because it reads this next value and then the end. So it's not going to care. It's very hard to screw up formatting of these arrays. However, if I leave out the end colon or the end curly bracket and get rid of the comma, you can see it expected a curly bracket before the semicolon. So just letting you know that there is a curly bracket missing. Now I can try and completely get rid of both curly brackets. And you can see here, initializer fails to determine size of R. Because it's not in curly brackets, it can't determine the size of the array, nor the elements within the array. So unexpected or expected unqualified ID before numeric constant. So it doesn't know what this is, so it has to be within the curly brackets in order for it to recognize this as an array. Now, if I don't put, remember the escapes, I have to put the slash and then the double quote in order for it to print this as a double quote. So if I try printing string again, you can see it prints a double quote in the middle. If I just put that there and try and compile it, this thing terminating double quotes character. So it treats this as one string, but it doesn't have the beginning double quote for this string. So again, you have to remember to use escape sequences. And those are pretty much the common errors for creating arrays and strings. Remember that to try this out, screw around with some of the variables and things, try to change it, break it, try it again, see what works, and that's the best way to learn this stuff. And I will see you in the next course.